Is space really just emptiness? When you look up at the night sky, what do you see? Thousands of stars? A vast, endless darkness? Or perhaps nothing at all? We often hear people say, space is just a big, empty void. But is that really true? Is space truly just nothingness? Hold on to your curiosity, because the answer might surprise you. In the next few minutes, we're going to explore the incredible mysteries hiding in the so-called emptiness of space. You'll discover that it's anything but empty. What do we mean by space? To understand this question, let's start with the basics. What do we mean by space? Space, or outer space, is the region beyond Earth's atmosphere. It's where planets, stars, galaxies, and countless wonders exist. But between these objects there seems to be nothing, or so it appears. This nothingness is called a vacuum. And while it's true that space has far fewer particles than Earth's atmosphere, it's not completely empty. Imagine this. In every cubic meter of space, there are about 15 hydrogen atoms. That's astonishingly sparse compared to the billions of molecules in a single breath of air on Earth. But these tiny atoms are far from insignificant. They're the building blocks of stars. Stars that light up the universe and make life possible. The stuff between the stars. And then there's interstellar and intergalactic space. It's filled with clouds of gas and dust. These clouds are the birthplaces of stars and planets. They're nurseries where gravity works its magic, turning chaos into celestial beauty. But space isn't just about atoms and dust. It's also a playground for invisible forces, gravitational waves and dark matter. Have you ever heard of gravitational waves? They're ripples in the fabric of space-time, caused by massive cosmic events like colliding black holes. We can't see them with our eyes, but we can detect them with incredibly sensitive instruments. They're proof that space isn't empty. It's alive with motion and energy. And then there's dark matter. It's a mysterious substance that makes up about 27% of the universe. We can't see it, touch it, or even fully understand it. But without it, galaxies wouldn't hold together. Dark matter weaves an invisible web that shapes the cosmos. It's everywhere, including the spaces we think of as empty. The quantum dance. Now, let's dive even deeper. On the quantum level, space is buzzing with activity. Tiny particles, called virtual particles, are constantly appearing and disappearing. This phenomenon, known as quantum fluctuations, is a fundamental part of our universe. Imagine a sea of energy, a constant dance of creation and annihilation happening at scales so small we can barely comprehend it. This invisible dance influences the universe in profound ways. Even the formation of stars and galaxies is tied to this unseen energy, the cosmic microwave background. And let's not forget the cosmic microwave background radiation. It's the faint glow left over from the Big Bang. It fills every corner of the universe, a relic of its fiery birth. This radiation is a reminder that space isn't just a void. It's a canvas painted with the history of everything. It tells us a story, one that began over 13.8 billion years ago, and it continues to whisper secrets about the early universe. Energy and field space also carries cosmic rays, high-energy particles traveling through the universe at nearly the speed of light. They originate from supernovae, black holes, and other powerful cosmic events. These rays bombard everything, from distant galaxies to our very planet. And then there are magnetic fields, stretching across galaxies and beyond. These fields interact with charged particles, shaping the behavior of matter and light across vast distances. They're unseen, but their effects are profound, influencing how galaxies evolve and even how stars are born. The cosmic web. The so-called emptiness of space is also home to vast voids and filaments that form the cosmic web. This web connects galaxies and clusters of galaxies, revealing the large-scale structure of the universe. The voids might seem empty, but they're a crucial part of the cosmic balance, influencing the distribution of matter and energy. Space-time and black holes. Let's not overlook the role of space and time itself. Space and time are interconnected, forming a fabric we call space-time. Massive objects like stars and black holes warp this fabric, creating gravitational wells. This is why planets orbit stars and why light bends around galaxies. Even time itself flows differently depending on the warping of space-time. And speaking of black holes, they're some of the most fascinating phenomena in space. These regions of space are where gravity is so strong that not even light can escape. Black holes might seem like ultimate voids, but they're incredibly dynamic, influencing their surroundings in ways we're just beginning to understand. Endless possibilities. Space is also the realm of endless possibilities. Within it lies the potential for alien life, hidden worlds, and perhaps even answers to the greatest questions of existence. Are we alone in the universe? How did it all begin? And what lies beyond the observable cosmos? A final reflection. So, is space really just an emptiness? The answer is a resounding no. It's a dynamic, ever-changing expanse filled with energy, particles, and invisible forces. It's a stage where the universe's greatest stories unfold. And the more we learn, the more we realize how little we truly know. We're explorers, venturing into the unknown. Every step we take into space reveals new mysteries, new wonders, new questions. So the next time you look up at the night sky, don't just see emptiness, see the possibilities, the wonders waiting to be discovered. Because in space, even the emptiest places are full of magic.